Hello, I'd like to do another example involving modulus and integer division. Excuse me. Here's the problem. I'm going to input the amount of change a customer should get. So how much, and that'll be in pennies, how many pennies we would give them if we were going to give them that. So it's cents. And I'd like to output the minimum number of bills and coins we should give the customer. So we would give him a $5 bill rather than 5 ones. We would give him $1 rather than 4 quarters, and so on. So here's an example. 672 cents is what I owe him. I'm going to give him a $5 bill. That's 500 of them. $1, that makes 600. 2 quarters, that makes 650. 2 dimes, that makes 670. No nickels, and then 2 pennies to get to 272. So that's the program I want to write. Now let's look at writing that program. So I'm going to close the solution and bring up, here we are, create a new project, and I'm going to call it making change. It'll come up in the usual way. I'm going to have a using namespace standard here. The main is the same. Oh, before I forget, in Xcode, there are 2 arguments that are inside here. I think they're okay. I think it may also be reasonable to take them out, but I'm not sure. Now, I need to read in the amount of change I'm going to give. So I'm going to have int change. That will be an input. I'm going to need some other values. I'm going to, let's say we're going to limit ourselves to $20 or less. So I'll have, well, make it, make it $10. Make it less than $10. So I'm going to need bill, let's call it 5 bill. Now I can't write 5, that's the first symbol, because variables have to begin with a letter. 1 bill, the amount of quarter, dime, nickel, and I think I'll go to the new line so you can read it, cent. That fell off the line, so I'm going to put it down here. And now I got them all together. You notice that I'm using words that mean something to me. You were doing that in Python, I hope. So you'd have to do that here too. It should be that you can go look back and not have to guess what the variables are. As I always say, we have to prompt the user. So to prompt the user, you use cout, and we're pointing the chevrons towards the cout. So we're sending something to the output. And we're going to put in input change, need it, in cents. I could put a limit on it. I just won't at this point. It won't work. But I'll put less than $20, less than $10. less than 1,000. I won't enforce that rule. I won't take off if the person does it. He'll just get bad results. It's known as GIGO, garbage in, garbage out. Now I'm going to take in the change. That part in any program or algorithm I give you, that's going to be the section where I say prompt and read. So if you see me say prompt and read, that's what I'm asking for, something like that. Now let's think. We had, as our example here, we had 675. We know that each $5 bill would be 500. So we want to know how many 500ths there are in 672. So all that is to divide 672 by 500. So I'm going to go back here, and I'm going to say the 5 bill equals the amount I put in, the change, divided by 500. I don't have to worry about getting a portion of a $500 bill because this will truncate. So I will have no trouble with having to figure out that it's 1.2 or something like that. Now, when I did this problem, after I had gotten rid of the 500ths, I had a 172 left. So I need now to get back to that. I have to have 172 before I can go on. So there's a reasonable way to do that. Why not take that, and I'll give this another name. I'll call this the remainder. Maybe easier to type the rest. I say the rest of it, after I give out the $5 bills, is equal to 5, the change, mod 500. Remember that mod means you divide and take the remainder. Well, the remainder, after I divide by 500, if it is the amount over the 500ths. So that's exactly what I wanted. It's what's left over. Now I'm ready to do the 1 bills. Be careful here, though. You're not going back to change. If you did, you'd be giving out 6 1s. You've already taken care of the 500. Now you're working at the rest of it. So it's the rest that we're looking at divided by 100 to give us that. And we do exactly what we did before. What do we have left? We have what we used to have left, mod 100ths that we're taking out of it. That's a very common kind of statement where you change a variable. We take the rest, which was originally a number, divided by 100, and whatever the remainder is, that replaces what used to be rest. Then we keep going. Now the quarters. I didn't use a 50-cent piece. I guess I didn't feel like my cash till had 50-cent pieces in it. Quarter. Now I'm going to take the rest again and divide by 25. That'll give me the number of quarters. And of course, the rest equals the rest give 25. Now I can do the same thing for the dimes. Equal rest divide by 10, and the rest equal rest mod 10. And then I could have, I'm almost down. I need the nickels now. Equal rest divide by 5. And what's left of the cents. So there's no reason using another rest. I'll just use cent there. So I'll just say cent equals the rest mod 5. And I got everything. Now comes the output problem. Now let's see what I want to do. I'm going to see out number of $5 bills. 5 bill. I want to label it as 5 bills. How did I label it over here? Let's take a look. I made it $5. So that means that I need to put in quotes what I want. Now I want a space between the 5 bit, the number, and the word. So I'm putting the space in quotes. I'm going to type what I want. And it looks like in this particular setup, I want these to come out on separate lines. So what I'm going to say is give me a \n. That \n says give me a new line. I'm going to do the same thing, and I made my usual mistake, putting a semicolon I didn't do. I'm going to see out 1 bill, same kind of thing. 1, I guess I called it dollar, didn't I? Not bill. Yeah, so I'll go back and change that. I'll make this dollar. I'll make this dollar. The \n again. And then I'll see out quarter. Q-A-R-T-E-R. Quarter. \n. See out dime, see out nickel, and we're almost done. See out cent, and I think I called it penny, so I'll put that in there. And I may, and now I have to put the return 0 in. Counting machine, I'm finished, and everything went fine. And then I'm going to erase all these things below here. They just didn't get in the mess. So there's the program. And you can see how it's quite reasonable that we have integer division and modulus. They're exactly what we want to solve this problem. And the modulus is going to come up very useful, to be very useful in many different forms. I just read something on the web that basically said if you got to do things enough, you're probably going to use modulus in something. So let's see if it works. I compile it, and there were no problems, and it's ready to work. So let's try 672. 672 is one $5 bill, one $1 bill, 2 quarters, 2 dimes, and 2 pennies. Exactly what I said. So let's try another one. Let's try 150. Now that should be exact. It should be a $1 bill and 2 quarters. $1 bill, 2 quarters. I could test it a few more times to make sure that it works for all the cases, but I think it probably does. So what I'm going to do now is I will copy this program over to what will be a handout when I put this out on the web. And you'll have both of them. Then you'll have the video and you'll have the solution to the video, not to the problem. And yes, that's the best I can do to get them to come on to anywhere. So this is the solution. Let's put it in. The whole point of this was to show you again how to use modulus and how to use integer division. You use those in the problem you're doing right now. Warning, they only work for integers. Don't use doubles. They don't work for them. And if you have a negative number modulus something is essentially not defined by the standard. We're not sure what the answer is. It depends on who wrote the compiler. Some compilers do it one way, some compilers do it another way. Some compilers say that the modulus always has to be a positive number. Some don't care. So I just stay away from them. I try not to have a negative number when I'm doing the modulus. So that, I think, would be a good bet, not to worry about that. Again, this is a program that is simply straightforward, nothing but assignment statements and inputs and outputs, plus the syntactic sugar, as I'll call it, of declaring what the variables are, having the braces, the int main, the import, the return, all those things that you have to get used to. I use semicolons to separate one line, one statement from what comes after it. All of these were statements, and the thing, so they all got semicolons at the end of them. Up at the top here, if you'll notice, there's no semicolon for the # include. That's not considered a statement we're executing. That's considered basically a command. Now it's kind of inconsistent that we do put a semicolon there, but those are the rules. You get used to them. Notice there's no semicolon after the main. So again, it's not every line gets a semicolon. It's lines of the statements that are going to be separate. They need to be separated from whatever comes after them. That's all I'm going to say now. I'm probably going to put out another video in a short time where we're going to start talking more about ifs and the booleans that go with them. So